Today we're going to talk about this machining fixture. So we designed this project in order to hold stock and machine it into holding bases for dial indicators. The reason we had to design this fixture was for mass production of the part. It would take too much time if we had to load each piece of stock into the machine, then probe each piece of stock, and then machine the part. So instead we designed a fixture like what you see here, where we can dial in the fixture into the machine, and the machine quote-unquote knows where the elements of the fixture are and can just go ahead and machine each block individually without having to reprobe or reset up, because the stock pieces are similar enough that they all fit into the fixture. So this saves tons of time in a production scenario. This is the only way it's effective to machine parts. No one would ever put in each part and probe each one individually. It's just not cost effective. So for this, we were making this fixture to machine little bases for dial indicators to hold them. So they're little 6061 aluminum blocks. I actually don't have one available to show. Our fixture didn't end up functioning as intended, so we didn't get a completed one. I'll go into detail about that later. But for just this introduction, this is our fixture design, and the purpose of making the fixture was to be able to hold those little aluminum blocks. So for this fixture, we had a few objectives in mind. Primarily, we wanted it to be able to hold both operations of the piece at once. So we had the initial facing and rough cutting to shape operation, as well as the secondary finish machining operation, where it pockets out the inside of the part. So we needed a fixture that could hold both. We were required to use these Mighty Bite clamps that we were given. So that's these ones right here, as well as these locating rails. And then this pin here, which got pushed down in our machining operation. I'll talk about that later. So we used the locating pin, as well as these. And then we were required to have the fixture fit in a Haas VF2 SS. That's what the machining was going to be done on. So obviously the fixture couldn't be huge. It had to be done out of stock that was this size given to us. So this was some Blanchard ground 6061 stock, so we couldn't get our own stock. We had to use this. That was one of our constraints. And then it had to have an ability to be mounted on the machine using the T-slots, and we wanted it to have some kind of alignment rail, so you can see along the back that machine surface allows us to dial it into the machine so that we get the X-axes lined up, and therefore the Y-axes as well. And then one objective of ours also was we had this probing hole there, so it would be easy to probe where the fixture was if we wanted to. And we wanted it to be marked, which was op1 and which was op2, for easier loading of the parts. One of the constraints was that it had to be able to be loaded and unloaded in under 1 minute, so marking the fixture helps with that. So in manufacturing this fixture, our group hoped to learn better how to use the Mighty Bite clamps. So that's these guys here. They're a cam lock style clamp. They're relatively inexpensive and compact. It's a very good way of work holding. So we wanted to get practice with how to design a fixture using those, as well as these locating rails. Again, they're from Mighty Bite and they're relatively inexpensive, a good way to locate parts on a fixture. So in order to manufacture our fixture, we started out in SolidWorks to make a CAD model of it. We started with the stock size of this block and modeled that as just a rectangular prism in SolidWorks. Then we took the 2 stages of the part before machining, so that would be the raw stock size and then after op1 of machining, and we mated them in an assembly with our block in SolidWorks, relatively where we would want them to go in the realm of the fixture. From there, we added Mighty Bite clamps as necessary in the assembly, where we thought they should be placed to hold the part. And we did cutting force calculations to figure out how many Mighty Bites we would need and if it would be enough to hold the part in place. And then we did FEA on the part to make sure it wasn't going to deflect too much. So that's finite element analysis using SolidWorks, which it didn't deflect enough to be an issue, using our FEA calculations. And then from there, we did some finishing touches on the part. So we added this rail along the back to align the part. And we added the T-slot holes. We added the probe bore right there so we could probe the fixture if we wanted. And then we made cam for the fixture and machined that. We actually machined it in the ME shop on the mini mill in the hangar. And then from there we assembled it using the Mighty Bites and put the pieces on to test it. And that's where we started sort of running into our first issue of many. So we ended up having quite a few issues with this design. So the first issue was that op1 goes right here, and the stock is a long piece of bar stock. And so what we ended up messing up on is that we were clamping and locating using this locating rail and this Mighty Bite off of two saw cut surfaces. Neither of those surfaces were fine enough to even remotely locate or be clamped on, and it meant that the saw cut had to be within 5 or 10 thou accuracy, which of course it wasn't. So that was the first mistake, and what we learned is that you never locate or clamp off of saw cut edges on a fixture. So we ended up having to machine all of our blocks of stock so that they would actually fit in the fixture, which was quite a pain. So we definitely learned our lesson there. We also learned that we should give the Mighty Bites more clearance. So there's not a whole lot of clearance here. They can't even rotate on these little cutouts. And so it's possible for them to get jammed when locating the part in the fixture, which is really, really annoying, and it would cause a lot of operator difficulty. So in the future, we would make these sort of recesses quite a lot bigger. That way the Mighty Bites would have more clearance and wouldn't get stuck. On this side for op2, we realized with our locating rails, we thought we would more accurately constrain the part by having two instead of a pin. We ended up over constraining it a little bit and it was harder to load. So we would want to replace one of these with a locating pin similar to the other side. And then same with the Mighty Bites, having two kind of over constrains it. So we really don't need this one Mighty Bite. We could have done with just one. And then so one of the important things when constructing a fixture is the datums. So you have to pick datums to make sure that your part that you're cutting is accurately located the way you want it to be for all of its important features. So in order to do that, we started with the first datum being the flat bottom of this plate. So that's Blanchard ground stock. So obviously it's going to sit flat or as flat as possible on the milling machine. And then because the top is also Blanchard ground, that's going to be parallel to the bottom and give us a nice flat surface to start off with our parts. So we wanted to make sure that we designed a fixture that we could set the parts perfectly flat on there and give us the best starting surface. From there, we needed one edge or one corner to locate off of. So on the op1 side, we have this locating rail, which locates off of one side of the stock and then bumps up against this pin, which locates the other side. And then that should be all we need to locate. So we have that bottom datum, as well as these two right there. And then with the clamping, it's constrained in all degrees of freedom, unable to move, and then located up against these side bits right there. On op2, we kind of messed up with doing the two locating rails. It really should have been one on the one datum and then a pin on the other. This is actually over constraining the part to have the two locating rails, which we didn't realize until after we had made it, that we really should have done another locating pin there. Same with having the two clamps. It's probably a little bit over constrained on the clamping for the op2. So that really should have done just one. So for manufacturing the fixture, we started off obviously with the stock, probed the stock on the Haas mini mill in the hangar, and then we had written the cam basically just using pretty standard tool paths to cut out all of these bores. nothing too aggressive, and then spot drill, drill and tap all of these tapped holes. One of these actually got messed up. We didn't realize in the CAD these were in the wrong location, so we had to re-drill those holes. Luckily it worked out okay. And then we had to drill and ream the hole for the locating pin there. That was relatively straightforward cam. And then as far as the cam for machining the parts on it, we had written our own cam, and when we went in and talked to the instructor, we were told that we could just use his cam, so we copied and pasted that, and we're wondering if that was slightly different or for a slightly different variation, or if ours was a little different and that's why it threw the part, because that cam had been proofed out. So we're a little unsure on that, and that is just a lesson to us, which is a fairly obvious lesson. We definitely should have known that always either do your own cam and or just proof through all the way before you run it. So from there, once we had the fixture machined, we went on to machining the parts, or attempting to machine the parts. And what happened on the very first facing op of op 1 was the depth of cut was way too thick. It was about a 1/4 inch depth of cut at 90 inches per minute. And the part ended up getting thrown using the big face mill, which did quite a bit of damage to our fixture. You can see kind of ruined the surface finish there. Put some big dents there, and kind of ruined the edges of the Mighty Bites. So at that point, we didn't have time to run it again, so I would also recess the pin back down into the hole. So it was quite a violent sort of crashing or throwing of the part. So we talked to the instructor, and we were told that we didn't have to run it again, but just to learn from our mistakes. So obviously we learned that always proof the cam over and over again. And also always check all the tool offsets to make sure those are correct. There's a chance one of the tool offsets was wrong or something, and that would be why it threw the part. So hopefully we get another chance to run this again at some point and actually get functioning parts out of it. In theory, the fixture should have enough holding power and should work, but that was just such a high cutting load that's why it threw the part. So in conclusion, we designed and manufactured this fixture to attempt to machine these little blocks to hold dial indicators. We were not successful in machining those blocks as the part got thrown from the fixture. We did learn a lot in machining our fixture. I think obviously one of the biggest takeaways was never to locate or clamp off of saw cut edges on the stock. You always have to locate and clamp off of either machined faces or like extruded faces or something that comes from the manufacturer. And then on the other side, we learned never to over constrain the part. So obviously that's just constrain the 6 degrees of freedom and no more. Having the 2 locating rails and the 2 Mighty Bites was too much. And then other than that, we learned to leave enough clearance for the Mighty Bites. So if we were redoing this, we would definitely machine these bores out quite a bit more. Let's see, what else did we learn? We also learned, and then additionally we learned that you should always proof the cam, like I said. That's why it threw the part when we were trying to machine the part in our fixture. So just always proof it before running it. And hopefully that wouldn't have happened if we had done that. So we learned a lot from this project. It was a very valuable experience.